a white paper. I've been working on it for a while and had some thoughts on it. I thank Christian for his work with the Green Carbon webinar series. I thank the two panelists, Hugh and Cecilia, for their contributions. I thank all of you who have given me a few moments of your time here today. Try to make things worthwhile for you. Let's get to it. All right. The one boring part, the structure of the paper, the white paper, which is called Climate Intervention with Biochar. The first edition came out just this past Monday. It's at my website, woodgas.energy. 52 pages, 18 figures, a bunch of tables and boxes, 25 sections, 1 through Roman numerals, and they're intentionally rather short for the most part, because otherwise it would be a massively large document and we want to have the expansion for other things later on. I'm going to assume that 5% of you have actually read the document, 25% of you have seen the document, and over 50% of you have yet to open the document. So I'm speaking to a wide range of people with interest. You are almost by definition well aware of biochar. You're not necessarily so involved with all the things about climate change, although it's certainly a topic of everybody's interest. The white paper itself has 3 parts with regard to negative emission technologies and how biochar fits in. The second part is with regard to how we actually get gigatons removed and reduced, and then some conclusions at the end. So what does this document provide? Okay. In the coming 15 minutes, if I don't get you hooked on this topic and awareness of it, then you might not stick around for the remainder of it. My job is to show you that, and I hope that you will be then dutifully inclined to stay. The climate crisis is upon us. We need to remove CO2. We need to reduce CO2. And I'd like to point out that we should be totally afraid of what is coming. This, oh, it's climate warming. It's the type of thing. This attitude is going to get us into a lot of trouble. So if you're not into the mindset that it is really a problem, maybe this presentation might help you to come to some of those conclusions. But I'm not an alarmist about it. This is not the purpose is about the biochar here. I'd like to point out that we are giving to our children a gigantic national debt. Terrible for us. Even worse, we are handing them a failing ecosystem. Can any parents, can any society be worse for its offspring than to spoil where they are living and going to be living? Okay, in the issue of the climate crisis, excessive CO2 is measured at 750 gigatons. That's excess in the air, maybe up to 1,500. Why the big difference? Because when we take it out of the air, the ocean is going to put some of what it has taken back into the air, and we're going to have to take out a whole lot of things, gigatons, billions of tons. Also, with our fossil fuel world, we are putting in about 40 fresh gigatons every year. We have to get those down to 0, and then we have to still get these other things removed, the excess removed. So it's remove and reduce. Biochar is a substance, but the process of pyrolysis produces biochar and energy. And I'm going to use the acronym BC&E, BC&E, or it can be just BCE, which pronounces wrong, BCE, not BC. BC is biochar. BCE, emphasizing the energy component with it. This is the process that we're dealing with. And the right way to name it in our discussion of negative emission technologies. Of the ones that are listed in the box on the right-hand side of the screen, there are 7 of them in there. And I'm taking that most of you are familiar with those. I'm not going to spend time on deciding them. I will say that I definitely go with DACCS instead of DAC, where they say direct air capture, and then that name ignores the and storage element that they have to have. So DACCS is the way I refer to it. And the other ones you're familiar in there. CCS, carbon capture and storage, as it is found in BECCS, is almost non-existent, doesn't work well. I live about 1 hour away from the world's largest and one and main only true BECCS project in the world in Decatur, Illinois. And I think the investment was over $120 million already in this one installation. It's not going to quite solve the climate crisis. They got a lot of work to go with. And BECCS and BC&E will be competing for the same supply of biomass. And so BC&E is going to be able to handle this. All the nets could be useful in the future. But BC&E is the clear winner now, and this is what I have to be able to show and tell to you about. There are diagrams and representations of it. This one is from Minx, very useful. We could go across. Here is biochar. Get that cursor over there. The biochar into there represented in it. And also Pete Smith in 2016 got it right in his chart. However, there have been many leading agencies that have got it wrong. The U.S. National Academy of Sciences, European Academy of Sciences, Carnegie C2G operations erroneously combine soil carbon soil carbon sequestration and biochar as if they were the same thing. This is incorrect, and I've seen things. I've written about it a little bit earlier on one of the papers that's at my website on it. The reason why they are different, there is a fundamental difference between elemental, stable black carbon, which is biochar, and organic carbon in biomass carbohydrates, which is what you have with soil carbon sequestration. And those will decay. One is stable, one decays on the fairly short-term line. This is an error which I say must be clarified, must be corrected. The biochar community cannot allow this error to continue onward. Okay? Now, the definition of nets, negative emission technologies, are just those names and things, and it really isn't very scientific. They're names of things and processes. I split it up into, in the white paper, it's this way. 3 ways, actually, the white paper is evolving. I've already have to make changes because in it, I did not mention ocean as one of the ways where CO2 leaves the atmosphere. Massive amount, but it's not a good solution. It causes acidity. We don't want the acidic oceans. So the only 2 ways that we're interested in encouraging is inorganic chemistry, which is unnatural, tends to be expensive, enhanced weathering, DACCS, they come into that, and organic chemistry, which is natural, which is photosynthesis. It's already happening. It's all over around the world. It's a major thing. That the plants remove oxygen, remove carbon dioxide from the air. That is, I think, a grade school science lesson, and we have to utilize this. Now, there's only 3 ways for long-term holding of CO2 out of the once it's been taken out of the atmosphere. The inorganic substances that are stable, turn it into rocks and into cement and things like that. Another one is if you preserve the organic material. Now, how long are you going to preserve this? And we need sequestration in terms of months, in terms of centuries. not in terms of short-term times. My one example is that the main spires in Notre Dame Cathedral, they were there for 1,000 years, and they still burned down, okay? Not too much of organic stuff lasts that long. And the other one, though, fortunately for us, is stable pyrolytic carbon. This is biochar. And a net, and if a true negative emission technology must be successful for both removal and for holding it out of the atmosphere so it doesn't go back. So I made this graph. This is a new one. First, the white paper is the first place where it's been shown. On the left-hand side, the two ways of getting carbon dioxide out of the atmosphere, photosynthesis, and then the sorbents, the inorganic chemistry that goes along with it. And on the right-hand side of that graph with a scale of permanence. Now, that's a logarithmic scale from 0.1 years, about a month, all the way up to hundreds of thousands of years. And the range of what happens for this holding. Crops only hold it in a fairly small period of time, for a year, year and a half, maybe. A soil organic carbon, but it can live on. I mean, it dies, but it can grow again. And this is the strength of soil organic carbon. I'm not putting it down as not being important. I'm saying, though, it must be protected so that it keeps living and will keep regenerating to keep that carbon from ever going back into the atmosphere. And we as humans tend to go around and mess up our soils again, and we release this carbon back in. So that's not so stable. And even forests are of a relatively short term, giving them up to a few hundred years. Now, the place of biochar is the potential for redirection of the photosynthesis of the plant life stuff into long-term holding through biochar. It gives us a permanence. What's the permanence? It's going to be at least several centuries, and it could be into 1 or 2 millennia, or even at the half-life of that. Things that are working on, okay? You can't, all right. By the way, there's also not just the removal, but and reduction, all right? BECCS and biochar and BC&E release energy. None of the other methods of the nets release any energy. They consume energy, or they're maybe neutral. Thermal energy has great value. We'll talk about that a little bit later. And small size pyrolysis units match up with the many multitude of locations where this biomass will be found. All of this works in favor of BC&E, biochar and energy. Must remove and hold long term. Neither BECCS nor BC&E does removal. BECCS doesn't remove, it's the plants that remove. And then they burn it all the way to ash, send it up the chimney, and try to scrub it out of the chimney. BC&E, biochar, doesn't remove any CO2 from the atmosphere. It converts stuff which is already there, that the plants did the job. Both of those methods are dependent on plants. AR is afforestation, reforestation, and soil carbon sequestration, SCS, but they are not designed to hold it. Take it out of the atmosphere, they do wonderful jobs, but to hold it, you cannot just keep forests growing and growing and saving them and saving them. It'll take up all the land space. We need to intercept that biomass and make it long-term sequestration. Carbon capture and storage is basically experimental. It's in pilot stages, quite expensive. I don't think that BECCS is something that should be getting, and it gets a massive amount of attention. There's only one combination of removal of gigatons and long-term sequestration, that's both of the requirements, that is operational now and with reasonable cost, it could actually be profitable. Agriculture is profitable. Take the waste refuse off of the land and turn it into biochar, and that you've accomplished the long-term sequestration. It is profitable, should be able to do that. So plant growth and biochar sequestration together our functional CDR, carbon dioxide removal, now. Major point to be made out to emphasize. Additional considerations about nets, and there's a section in the white paper about this. I'm not going to go through all of them, but I want to point out that all of them are favorable or acceptable with BC&E. It's the social issues, justice and inclusivity, it's additionality, permanence, delivery time, confidence in removal, all of those topics. They're in the white paper, not for our discussion at this point here, but we do take a look at those, trying to identify them. And section 5, Roman numeral 5, biomass supply for pyrolysis. In the USA, we have 1 billion, and I've seen a report that said maybe 1.5 billion tons per year of dry biomass equivalent without upsetting production of food and fiber. Okay, that's a gigaton of biomass, 1 billion tons. How much of the world is the USA? And you can, calculations get pretty wild when they're talking about Amazons and otherwise, but we're not trying to deforest the Amazon or anything else. But if you're looking at useful things, if we cannot get like 10 times across the whole rest of the world, if there's not another 10 times the amount of biomass that we have, then there's something wrong in the calculation somewhere. So I'm saying that there's between 15 and 25 billion tons per year of measured as dry units, biomass that could be available for pyrolysis. And I'm not saying that the 25 billion is now, but we have 20, 50, 80 years before 2100 to have improvements in agriculture and forestry and genetics and things that we're able to get things going. I don't think 25 billion tons a year is unrealistic. I mean, it's going to be on the high side, but it's certainly not that we're short on biomass. And in terms of getting started now, it's all over the place. We can't even get rid of some of the stuff fast enough. So there's more discussions about these in the paper as we go along. I'm nearing the end of the first segment of the talk here. I have this chart. This comes out of the conclusion, and it is my projections based on other parts which are in the white paper, which we're going to talk about in our second half or second third of our presentation here today, about where we get these numbers from. But on the right-hand side, you'll see cookstoves, crop residues, forest safety, urban tree waste, home heating, and there's numbers projected out onto there. And I think I'm making a case for those numbers being reasonably valid. I would expect to be taken to task on some of them. But please note that by 2030, we should be having, the bottom red line there, we should be having at least a gigaton of carbon dioxide removal from all of these different things functional. And 30 and 20 years later from that, we should be up in the neighborhood of 4 to 5. And then in the second half of the 21st century, in all of those years, we should be able to be above 5, 6, 7 and gigatons of carbon dioxide removal taking place. I'm almost always talking about carbon dioxide removal. I am not talking about tons of carbon and biochar, because there's conversion factors and things like that. The world operates and functions in terms of carbon dioxide removal from the atmosphere and the CO2e, the E for equivalent. So cumulative in 70 years between now and, let's 80 years now actually, but before the end of this century, 300 to close to 500 gigatons of permanently removed biochar, or permanently removed carbon dioxide by using methods that relate to biochar. Please note that this, even the top number there, does not even cover 10 years of our current emissions. We must have reduction of our our carbon emissions from the fossil fuels. That will also be discussed after I come back from the pause in here. So that you don't run away, here's what's coming after the break. All right. How did we get to these numbers of all these gigatons, and what projects, and in terms of who's doing it, and financial aspects? Also, there's one on the wood gas impact initiative. This is with regard to verifications of it. This is a major topic. I have a whole project that relates to that. There's a couple sections in the white paper about it. We want to at least mention it, although it's pretty tough. It's pretty strong computer science and things like that. But we are able to do that. I would talk about the carbon reduction side of BC&E. This is where how in the process of pyrolysis, we're making heat which can offset fossil fuels. There'll also be a discussion about the BC&E technologies, the methods and devices for the 21st century, including my presentation stuff, a new fresh material that hasn't been presented before, about variations of rock kilns, and some things which hasn't been shown anywhere yet. In fact, it wasn't photographed until yesterday. And I'll also discuss on why has biochar been overlooked for the CDR purposes. How can we get to today and this white paper without having this capability of biochar just screaming at us that this is something that our societies must be doing? So that's the point where I get to take a break, and I'm actually probably even going to not appear on the screen all the time, so that I let the other people have their discussions on it. You don't need to see my reaction when Hugh talks and I cringe. Like, oh no, he said that. No, I don't need to do that. But okay, so I turn it over back to Christian and the panelists.
Thank you, Paul, for your introduction to the difference between different nets and biochar and energy, and about some of the possible advantages of biochar and energy. And I see Cecilia's already here. So I think as you're a professor for industrial ecology, I think you can probably add something on the difference between BECCS and biochar and energy, because I think there's another dimension if you actually produce a product beside of the energy.
Yes, thank you. I should perhaps also mention I do work at KTH, Royal Institute of Technology in Stockholm, but I'm now, since the beginning of this year, Associate Professor in Bioenergy Systems at the Swedish University of Agricultural Sciences. So I'm coming into this from climate impacts of bioproduction systems. That was my entry into biochar, finding biochar very interesting, specifically from the climate impact. So that's where I've been doing some research in the past years, and that's why I agreed to take part here, because I find it very interesting that you are making those connections between biochar, energy and climate, and it's not so often that that is done. And I think we need those aspects in order to understand this, and I agree that biochar is a very promising carbon dioxide removal technology. It's got the benefits that it's already here, it is scalable, and it's got these additional benefits of using the biochar. And I saw a question here coming up, and I think that is a question in the chat. I'm not completely responding to it, but inspired by it, saying that there is something interesting here in terms of efficiency. And you mentioned that in your report also, that people in the energy field and bioenergy, they normally focus on energy efficiency. And if you have that in mind, producing biochar, not burning it to get all the energy out of it, and substituting as much fossil fuel as you can, often seems like less efficient use of the material or the energy feedstock that you have. Whereas with biochar, we do get the carbon dioxide removal, and that is a rather new concept, and I see it evolving now quite quickly in the past few years, being clearly defined as something else, not being this geoengineering where the negative emissions have been grouped before, also not being just climate change mitigation and reducing emissions, but rather removing emissions. And there's still not complete understanding everywhere, and not a well-developed terminology yet. So we'll have to keep that in mind.
I have
maybe
some comments I would like to toss in. My background is more in chemical engineering, and one of the, I tend to draw analogies, and one of the things that I've sort of just sketched out for myself is that there is a sort of a functional equivalency between BECCS, BECCS, and this biochar and energy, in that if you were to capture the carbon dioxide, which is generally done with amine scrubbers, you actually, and people have seen these numbers many places, derate the thermal output or the electrical output of the plant. These are generally large electrical generation plants, by about 30%. So if I have a 100 megawatt plant, I'm going to have 70 megawatts of actual usable power if I have to divert 30 megawatts to run the carbon capture system, just the system. I haven't stored it yet. So let's set this 30% energy loss and this CO2 gain into a box, and we have an electrical plant that's putting out electricity for the remaining energy. If I do BECCS, about BC&E, I actually also lose about 30% of the total potential energy in the biomass coming in. That leaves as the biochar carbon that is not oxidized. And I have heat. So I have basically somewhat of an equivalency that if you were to do carbon capture and storage, BECCS and the biochar route are thermodynamically very similar in the sense that they kind of offset. They both they both sacrifice 30% of the potential energy of the biomass coming in to accomplish a goal. In one sense, you get CO2 back, and the other sense, you get biochar back. At that point, you can start thinking a bit about whether you'd prefer to have condensed carbon dioxide or biochar, and whether those materials have different values subsequently in the ecosystem. And I just wanted to bring up that parallel because it simplifies the comparison of choices between these two. Thanks.
Yeah. May I add to that? I think you have a good point there, that there are similarities in that sense with the BioCCS and biochar, that you lose some of the energy. I just wanted to take the chance here to say that we often stress electricity power generation, and there's a point in that, but there's also a point to give a little bit more attention to thermal energy. I think Paul will continue there, but we needed to heat our buildings in a large part of the world at least, and to cook food everywhere and for industrial processes. And I think both BioCCS and biochar have their strengths in relation to thermal energy rather than electric energy.
Thank you, Cecilia. We have one question from Joshua from the James Hutton Institute. Whoever wants to answer that. So he throws out the question of even if there are 20 gigatons of biomass available, So how much of this can actually be pyrolyzed into long-term stable biochar? Because that's the overall question of availability, I think, because we often hear a lot of numbers of how much biomass is available. And I think that's something that also has to be addressed if there are any constraints on biomass for BCCS or for biochar and energy.
I get into some of that in the second part here.
Okay.
So yeah.
So we keep that for later. And then we got another question, which I think, looking at the time, is the last question for the first part. So the question of the effects of biochar in the soil, because we are often talking about how much biochar can be produced and how much carbon it will store, but obviously the biochar also will be applied to soil. And what do you know the effects or the long-term effects on different soil biology, ecology, about the storage capacity for biochar in certain soils? I think that's summarized what was asked from.
Let me make a comment on that. I am not an expert on that line. I have my other things to put in. I yield to the expertise of all these other people, reminding everyone that there is the National Biochar Week webinars, which are going on this week, and a half an hour after we end, their session for 3 hours starts, and it's a free one. If you haven't signed into it and you're interested in, know that that's coming up. So it's such a broad topic, and everything is a valid question, and we need to have many people trying to answer them. One option says you take this biochar and you put it down into old coal mines, basically refilling it back up. I mean, the problem is you could dig it up and burn it again, and that wouldn't have been sequestered. But right now we're taking coal out of there or oil out of the ground, and we're burning it. If we just put it in the ground, that takes it out. So it doesn't have to go into soil, but there are good reasons that it should go into soil. Okay, we're ready to go on?
Cecilia, do you have something to add to that?
Yes, just briefly. These are important points, and but it's so specific. Where, in what soil, ending up then in what water body. So it's much more difficult for those things that are asked about the environment, the effects in soils, to make a general overview with the biomass, the wood, the energy, and conversion to biochar. It's easier to scale it up and get rather robust estimates at the global level.
I also think there's a distinction between biochar that is storing carbon in the soil and being resistant to degradation, and biochar that is synergistically benefiting the soil by hosting microbes and retaining water and nutrients. The storage mechanism is functionally limitless versus the amount of dynamic biochar in the growing system, which has a much higher value. And you might say has a limit, but I don't know it's a practical limit within the level of activity that we're going to be able to achieve.
Yes, I think that's a good concluding remark, that at this point, at least, we're not close to over-saturating our soils with biochar. So I think we will continue to the next part from Paul. Are you ready?
I will endeavor to probably finish off what I'm presenting within the next 15, 20 minutes, and then we'll have all the rest of the time for panelists and lots of questions and stuff like that. So not 3 parts, but sort of the 2 parts here we'll go into. I previously listed some of these different topics that we're going to look at. They're not all in necessarily the organized order, but it's in the white paper. 7 reasons why this net called BC&E or BCE has been previously overlooked. One is there has been a lack of appreciation of long-term stability of elemental carbon in soils. It's just not part of our discussion. Biochar has not been, as far as I am aware, a significant part of soil science education, certainly not in the basics. It gets mentioned, they know about it, but it's not their driving force. Soil scientists have not gotten on the bandwagon for, oh, how we could use biochar and it would have carbon sequestration benefits. The biochar enthusiasts have been focused on plant growth and soil issues and relatively small amounts of biochar. They're not talking about gigatons because they haven't had gigatons to deal with, so they've ignored it for the most part. A lack of any official allowance for carbon credits. You can't get money from the CDM processes and things if you're burying your char. It's required that it is used in a different way. To give examples of that if you'd like. Number 4, biomass energy production has been seen as renewable, but not as carbon negative. Burn it all the way to ash. This is where the 100% efficiency that Hugh was mentioning, that's been the mindset of those that are in that realm of industries. Also, the elephant in the room is these low prices of fossil fuels. They are killing everything that relates to renewable energy and these prospects into here. The privileged position of fossil fuels, including subsidies and no emission taxes, must end. You can quote me on that. I'm a anti-fossil fuel embargo or cartels or whatever else that they've got going on with it. They won't like to hear that, but that's too bad. They are the cause of this. And now that we know it's a problem, you cannot turn a blind eye and pretend to be on the side of society in the future if you're not cutting the fossil fuel down to net zero. Number 6, biochar production has lacked profitability. There's no reason for doing. People weren't driving for this. And my part into here, only in this year have I come out with this new low-cost technology called rock kilns, RoCC, and I will mention them as we go along. Any combination of those 7 in there has been enough that it just didn't gel. It has not been on the radar that biochar is the best net, the best carbon removal capacity that we've got. This is a couple charts in there side by side. The one on the left-hand side, it points out that of the world's consumption of energy, 51% of it is for thermal uses. 32% is transportation, 17% is power. Power is like king, and transport is like the queen, and thermal is like, oh, the peasantry or something like that. I mean, we've got to give recognition for this. And by subtracting out the smaller boxes in there of the renewables and non-fossil ones, about half of the, about 40% of the total world consumption of energy is fossil fuel burning for thermal purposes. And that includes thermal purposes that will get you air conditioning and stuff like that. 40% of the, yes, 40% of those 40 gigatons that they're kicking up into the atmosphere every year, all we have to do is replace the heat. That's the easy stuff. This other part over into here, almost 80% of the whole numbers is the fossil fuels. This one is, there you can see, traditional biochar is shown over here as a burning, and this includes the cook stoves, includes charcoal makers and things like that. But we've got to increase this. In this chart into here, one way to get to net zero is for the entire box to get smaller, meaning less amount of energy getting lost into there. Well, that means we're living with less energy. Not too likely. We're more likely to need to have replacements of those fossil fuels. And we want to use the heat that's coming from biochar and energy. Here's that graph that I showed you out before, and I'd like to call your attention to the green line here. Subtotal ALIA, defined as areas of labor-intensive agriculture. That includes many places in Africa, and also includes many, many places in China and in India, which are certainly not least developed countries. You can't, I mean, these are, but they have areas of labor-intensive agriculture into there. And we're going to be discussing some of those specifically as it goes along. Then we have forestry and urban. We can come back to this at any time for in the discussion point time. In contrast with the carbon emission, the carbon reduction, here is carbon, in contrast with the previous slide, which is on removal, this is on carbon emission reduction, abbreviated as ER. And there's basically, in the upper ones into here, cookstoves, crop residues, forestries and stuff, there's almost no significant impact of reduction of fossil fuel use. It doesn't relate to fossil fuels when the people are cooking with their cookstoves and with making our forests safe out in California and stuff like that. However, on the other side, we're looking at electrical power generation, home heating, and process heat. And I think that the numbers are on the far right-hand side into the gigatons of CO2 removal per year. And this is being subtracted from our current about 40 gigatons that we have to get down to net zero. So even with using this energy from it, we're nowhere close to getting rid of all of this the need for fossil fuel, just because we have the biochar. There is a section in the white paper, and I refer you to it more for reading it rather than me going through the details. This is on multi-century sequestration that needs to be documented so that we're able to implement our financial incentives for rigorous accounting of the removal of CO2 from the atmosphere. And I am involved with one initiative. It's called Wood Gas Impact Initiative. We're using the CharTrack software system, which is already has been used in one community project in India. It's got blockchain. It has Internet of Things. It has, can it grow into having artificial intelligence and artificial neural networks? These are things which are work in the background to help make all of this possible. I am very much working on that. Anybody that's involved and interested in that component of it, please contact me. My email address is around. We're looking for investors. We're looking for places to put it to work, those types of things. And in the paper, there is a short discussion of a case study that's happening in Assam, India, at the Jarlinga Tea Estate, very cooperative, cooperating owner of there, Mr. Ketan Patel, and we're going to be doing some of the work there. So it's not just talk, and we're putting things into practice. We're looking for more of that, but we have to have this with rigor. Sources of, oh yes, I have a bunch of sections. This is a summary here of a bunch of sections, and I'm going to have a slide on each one of those about world charcoal, about cook stoves, about crop residues, tree growth for fire safety, disposal of that, power production, residential heating, and industrial process heat. The section on every one of those in the white paper, and now I'm going to just touch basically, briefly on some of them. Advanced BC&E Cookstoves. This has been my specialty. I got started in this in 2001. I can go on for hours, and I have. I've presented over many times over. But we are looking at having 1/4 of a gigaton of CO2 removal being done by the poorest 20% of the world's population. That's 250 million households, simply by giving them or getting to them a cooking stove which is modern, efficient, and it happens to be a biochar and energy pyrolytic charcoal making gasifier stove. On the left-hand side is the natural draft version. There's pushing close to 100,000 of those units now in India. Been some recent changes over there. The two on the right are both with fans, and the middle one, the fab stove, will be coming for sale in America at American prices in probably in January. So it's made in South Africa. I'm involved with this one. Full transparency, yes, I'm involved. I work with all these people and the types of stuff and help out with it. So, and that is only the bottom 20% of the world's population. The next to the bottom 20% of the world's population gives us another 2.25 gigaton per year of carbon dioxide removal just by being nice people and helping out the ones who are the poorest. We have to do better than this. There is a section in the paper, in the white paper, where actually I am lamenting about how wealthy, how we could accomplish this with so much money. Just lend the money, do something with it, plead with it. So if you know anybody that's got anything that knows somebody who knows somebody, let's get in touch. This is something they can get their money back if they need it, but we have to have the upfront capital to make this happen. This is the no-brainer of the whole thing. This is out of the 250 million households, $10 billion. $10 billion, that's less than 10% of Jeff Bezos' money on his own. And there's other billionaires. I mean, there's so much of the money is around. Governments can do it. Regional banks can do it. And they can get their money back if they needed to. It's in the paper. The advances of BC&E technology, I'm going to discuss them, but I like this diagram because we are dealing with more than just the charcoal product, the biochar. We need to look at the thermal energy. We need to look at, we've got to get rid of this stuff. Biomass disposal, it's a landfill problem. It's a fire hazard. It's giving bad air quality. And the other benefits, which include chemicals and carbon offsets and the climate benefit, if for no other reason we need to do this for the climate. How can I emphasize that enough? It's okay. In the last 10, 15 years, there's been some development of combustion technologies for pyrolysis. On the left-hand side is a figure of the flame cap kilns. I call these open cavity kilns. A cavity with no air entering in at the bottom. You throw in the fuel, the charcoal accumulates in there. And it has an open top. There are cavities, and there's other presentations given about that. That's been around for 10, 15 years. People have been working on that. Lots of Kelpie Wilson will be talking about more of that today at the U.S. biochar meeting that's going on. The other one here is a covered cavity kiln. And I've got some pictures coming up for that. Same process, a char accumulates in the bottom. The heat up above does the pyrolysis. And the problem of both of these is that if you just throw in the fuel, you're at risk of burying the fuel underneath other fuel. It doesn't get enough heat. It doesn't pyrolyze. You get insufficient pyrolization and insufficient pyrolysis. So therefore, in the latter half of last year, a year ago, and now in 2020, I have come up with a way to rotate that, to tilt it, to roll it, to make it so we can mix in here. And it's the rock kiln, rotatable covered cavity kilns, RoCC, the rock kilns, which I'm going to show you some pictures of here now. There's some other presentation materials around that you can get to, but I'm not wanting to repeat anything. Here, the one on the left is a 4-foot diameter unit, and they're just on the part of the cycle ready to empty some of the fuel out, or rocking it back in that side. The one on the right hand is an earlier version of the rock and roll kiln, which is, I'm going to show you now. This is rock and roll. First time ever seen pictures of the unit that was built last week, late at the end of last week. Put it together, took pictures of it literally yesterday. Got things on, the barrel's been fired up before, but the wheels and things are new. This is something that I would like to go through, and maybe in the question period, if people are the ones that are interested in staying on at the end, we can go through the stuff about the rock and roll barrel kilns and making it even bigger than this barrel. New ideas coming every day about it. There's a picture of the component parts of a rock and roll barrel kiln, and too many details to be describing for you at this particular time. We can come back to this, but this is real, it does work, and I've got a lot of details about it. On the same principle, there's the rock and roll, but much larger, taking it like 6 feet, 2 meters across, maybe even longer. And a couple people pulling this thing through on the wheels into here, going through the fields, as in the case that's written up in the case study of Punjab in India, where you're going to bring in you've harvested the crop. They have all the stubble and the crop residue out there. Instead of burning it off and giving the haze into the atmosphere and all the climate problems and stuff that are associated with that, air pollution, we want a unit like this that we can take through the field. We bring it on, you put the fuel and stuff actually on top of the shelf into there, which is between the handles, and you can raise it up and tip it in. It's not yet built, has not been built. It's only in the design capabilities. We're looking forward to finding ways that we can get some funding, people that want to be doing this. I will make a point here. If anybody says they're going to wait around for Paul Anderson to have it built, you're on the wrong boat. You're going the slow route. I have to have other people doing things. All this stuff has to get beyond me and get beyond me quickly. Biomass disposal for fire protection, the California fires, Australian fires, and things like that. We need to clear out. This is a massive amount. We're going to have in the Biochar Week presentations today things about forestry in there. And they will also talk about slash, what's left out into there. We can take these rock and roll kilns out in any place where they're able to put logging operations in, and you could have kilns out there that are making this biochar and being able to make it happen. On the other, an additional in terms of tree growth, urban wood waste. A community which is paying to collect its trimmings off of trees and stuff like that could have an appropriate kiln, and I don't say it has to be rock and roll. This is one of ones to consider. It could be other types, but I'm not dealing with $500,000 or $250,000 installations. Rock and roll kilns and the rock kilns are not that expensive, but they're giving off the heat, giving the biochar, giving the heat. This is something where we want to have the expertise of the engineers that deal with those quantities of heat, and we can use it for drying of the fuels that yet to come in. Need a lot of help with this. This is part of the transition for the 21st century, and this is the $1 trillion economies that have to be coming along with as we go to net zero in terms of fossil fuel usage. Also, pyrolysis for electrical power. There's an example in the report about California. I think Josiah, no, not Josiah. Yeah, Josiah Hunt for that. And then the picture on the right-hand side is the smaller. There's bigger one being built. This is for electricity that uses charcoal as the fuel. Much cleaner, much smaller. My co-worker with all this is Gary Gilmore, who's a now retired forester in Pennsylvania. We can go on in depth about that, smaller units.
Hi, Paul. I think we're running a little bit late already.
Okay, I'm almost done. Okay. Residential heating, massive numbers of things. I can talk to you about that, and that's in there. Industrial process heat. This is beyond my level of expertise. Must depend on the people who will listen. Tom Miles, I hope you'll hear this eventually, and I certainly would like your inputs and those from other people. Financial value, they're trying to find a way to, these are the co-benefits. These are the things which other people on this webinar, the biochar people, can contribute to, and they handle to it. Conclusions in here. I put this out. If we cannot promptly implement these comparatively easy, benefit-rich biochar and energy initiatives, we will lose the battle to save our planet. You can't turn your back on the easy stuff and expect to then win the battle with some high-techy thing that's further down the line. This is in my thing, I'm emphasizing that. The conclusions, watch out for the moral hazard, affluence, and poverty, and all these are topics which are dealt with in the report. I'm concluding by saying we are talking about a climate crisis. Biochar happens to be the tool in here. This is not a typical biochar presentation about how the earthworms are benefited and the water holding capacity. Those are the extras that come in. Calls for action, and I turn this to all of you. Please direct people to this white paper. Please tell your friends and find the movers and shakers in your community. Find the people who have some funding. We'll match up people around in different ways, and stay informed and be informed. That's my quote again that I had already out, and there's the end of my slideshow. So I can go back to any slide that somebody would want to, if you want, according to what the questions are. I'll just leave it at this one, or I might change it as we go along. Okay, thank you. I've actually gone through everything that I plan on saying, and it gives us some time for 20 minutes or so to have all the comments and the questions. And I will mute and go off again a little bit. That gives me a chance to drink water without everybody watching me.
Thank you, Paul. So we got one question from Saren Sohi before, which is about the acceptability of pyrolysis cookstoves. And I think both Paul and Cecilia has some experience with the practical usage in developing countries on that. If you can, if you have something to say on that.
Yes, I have some experience from one country, from a research project, and one piece to start with is the availability of fuels. Some people, rural areas, they have good access to fuel and they are happy to cook on their open fires. But a lot of people, both rural and urban, are really short of fuel. They're struggling a lot to achieve fuels, and to be able to save fuel by using this cook stove can be enough of a driver for many people. It is definitely a change from using an open fire, which is very flexible, to using one of these cook stoves where you are locked in to have a batch process. You fill it and then you run out. You have a certain amount of power and perhaps not so much flexibility in power, and you need to learn to handle the device. So on top of actually getting it, which might be a cost, it's also a learning process. And if you don't have some other driver, you might be lost in that process. But if fuel shortage is really troublesome, then that can be enough of a driver.
I agree.
And the next questions that came up during the presentation was, so we saw now we saw cookstoves that actually use the energy, some of the heat energy produced. But what is with the RoCC kiln? It's not really a biochar and energy process yet, if we don't use the energy. Or or questioning it in another way, for crop residues, you produce thermal energy in the field. So how would you be able to actually use it, or would that be an issue?
Okay. Hugh or Cecilia, want to comment, or?
No.
Yeah, actually, repeat the question so I can address. So we get multiple questions popped up in the air. So what's the focus? I was reading the chat lines, unfortunately, when you were asking the question, Christian. So I will ask you to repeat yourself.
So what for BC&E we need to actually use the thermal energy produced, and for decentralized systems often you will be out in the field where you don't necessarily need thermal energy directly, and I wanted to bring that topic up, that is a constraint for some applications of biochar.
Well, I think we have to be reasonable about how small an amount of energy we want to be trying to capture and use. Frankly, most of the biochar devices don't produce either high enough quality energy, in other words, the temperature's not hot enough to generate steam for power generation, or the volumes of energy that are involved. And when you look at a wood powered electrical plant, a biomass power plant, you're talking about 1,000 tons a day of wood. This is not Cookstove type scale. I want to postulate the following scenario, and I've used this for years. We, as a civilization society, have hundreds of devices that use a renewable fuel, typically wood or some kind of biomass waste, generate usable heat, quite often for heating or heating water or cooking, and create ash. And ash has very little value in the current cycle. What would the scenario be if we had hundreds of devices, hundreds of choices that consumed a renewable fuel, typically wood, generated usable heat, and created biochar as a byproduct? What would be the dynamic change between the economics of this ash generating heat making device using renewable fuel versus this biochar creating heat making device? How would that change the dynamics of renewable fuel sources versus fossil fuel sources, which is frankly where the battle is lost when you've got fuels as clean as methane and propane, and you know, even diesel doesn't really smell anymore. So we need more choices. Cookstoves are the first example of a very small device that addressed a real serious health problem, more of indoor air quality than particularly a fuel problem or an emissions problem. We need these devices at all scales. We need pellet stoves that generate biochar. We don't have those. We have pellet stoves that generate lots of heat and ash. So it's you know, a chicken or an egg kind of thing. We need more designs, and then we'll see more consumption.
I'd like to add two things. One, first, thank you, Hugh, for mentioning pellets. Wonderful fuel. It's made in quantity. We can put it out, and this should be one of the directions we go to. Nobody burns oil as it comes out of the ground. Everything is processed, gasoline or diesel or something else. Why do we think that we have to just use a chunk of wood because that's the way it grew on the tree, and it's wet and it's green and everything else? We process the other stuff. We can certainly process biomass and make it usable. And pellets can be, I mean, it's moved by augers and vacuums and all kinds of different ways to distribute it. Europeans are far ahead of America with regard to pellet fuels. You can pelletize this ag residues that are being burned in the fields in India, etc., but that's an extra work. I mean, if there's money involved with it, if it can be worth it, do it. We're trying to stop having the air pollution, and I don't really have any problem with throwing away all the heat that's generated from that, because we've accomplished one of the other of those four major objectives that we've got. Nice if we can use the heat, but there's the expression, the perfect must not be the enemy of the good. I mean, I'm expected to do, not me, I mean the process, the technologies. This needs hundreds of people, needs thousands of graduate students and their professors, etc., working on this problem like we worked on nuclear energy, or like we worked on the oil industries in the past and things like that. And there's nothing being done. We don't even get into the grant processes and stuff like that. It will be done when the ingenuity, the engineering capabilities, the science and stuff do it. It's sort of like, when is the population going to wake up that this is what they're going to do? It's going to cost them some money, but the other alternative is, if it's an existential threat, if it threatens your existence as a society here and 100 years from now, I think it's worth putting some money and effort into it. It doesn't go to me, it goes to all these other people. But that we have not yet even scratched the surface of what can be done with the rock kilns.
Thank you, Paul. Cecilia, I think you wanted to say something before?
Yeah, but I think Paul brought that up with this agricultural burning in many Asian countries. It's really a huge air pollution problem. And any solution to that air pollution problem is good. If it produces biochar as well, it's even better. So we shouldn't demand that the heat is also used before we start doing something.
Mm-hmm. And so to follow up on that, do you think that might be like a door opener for people in these countries, for the actual people who will do the job of producing biochar, to target the air pollution problem more than the carbon sequestration issue?
I'm going to say no. We don't care about that. These people want to be agricultural workers. They want to have a job. They want to have some food on their table. And if they get paid with this money that should be coming from the wealthy societies, which are trying to encourage and save the planet after we've been gumming it up with so much fossil fuel burning, there should be $100 per CO2 ton removed, equivalent ton, which would be about 300 kilos of biochar. And they go through the fields, and this money comes in, and you start dividing that down into it. There's some calculations in the white paper. There's enough money to probably double the wages during the season of the otherwise burning of the workers in India, for if they did it the biochar way instead of the other way, and we gain air quality.
Let me interject that biochar or carbonized biomass is a fuel, or it's either charcoal or biochar. It's really the outlet for it. So in many of the developing countries, the char making stoves, they take the char and they pelletize it, or they briquette it, and they sell it back into the charcoal market as a fuel. So basically it comes down to economics. Unless you've got an economic entity, and that should be perhaps the government to get the process going, buying up the biochar to prevent it from heading into the charcoal market and being sold as charcoal, the person creating the biochar has to derive whatever revenue they can from that effort. And so we need to be basically competing against the charcoal market. Now, there is a benefit that briquetted biochar probably is more efficient than making lump charcoal the old-fashioned way. But again, I think it's a market driver, and I don't think we can drive the obligation down to the primary stakeholder, the person who wants clean air inside their hut, that they also should address climate issues. They really are not in a position. We as a society have to make the economic flows worth that, and we basically have to buy up the carbon and perhaps sell it back into a different market.
Mm-hmm.
The history of cookstoves is actually full of a lot of great examples where people do the right thing for not the reason you gave them, but rather because there's this ancillary benefit, either of cleaner air where they're cooking, or in the case of the Anila stove in India, the women sell the charcoal to the blacksmith and get some income. So it's a micro income for the mother, who can then feed her children. And so that's the benefit. That's why she bothers to switch to this stove, not because it's easier or faster or, God forbid, the right thing to do for the climate.
Yes, that's more of that's in the direction I wanted to touch here. That in the whole history of biochar research from the last 10 years, there was always this idea that at some point developed countries will pay for carbon sequestration. First, we thought they will pay for it in the developed countries itself. Then they changed to developing countries, and we are still at the same point as 10 years ago. So my question was if you see any benefits in combining things like health improvements or income from charcoal selling to the carbon sequestration goal, if we have to combine them to actually get this thing running on a large scale, or if you think carbon sequestration is enough of a goal to actually get through, because we see it's not really getting through the last 10 years.
Yeah, may I start there? I see a lot of change in the past 2 years. We had a girl in Stockholm starting to go on strike on Fridays. And the whole of 2019 was global climate strikes all across the world. This has placed climate on the agenda. Our politicians have had a lot of other trouble to worry about this year, but it's still on the agenda in Europe, in America, and it's also on the agenda in the private sector. A lot is happening in the financial sector, in big companies, and they are waking up and placing these fancy net zero goals. Some companies are doing this just to distract from what they're doing right now, talking about, yeah, in 2050 we're going to be net zero. But many of the companies are actually serious about this and starting to look at what is there. It's very difficult to go net zero today, so we need some negative emissions to balance. And there's money coming in and there's interest from the financial sector. So I think it's really time now to bring biochar on the agenda, because there is a story here about climate improvement that is also improvement in many other ways and can help poor people. So there's really a story to tell and to sell. And I think that is a change from where we were 5 years ago. More people will be listening.
I'd like to second that, and it's important in there. One of the questions that I have is, how long will it take before a copy of this white paper, or at least the summary or something of it, reaches the desks of the decision makers and then you name the company, whether it's Microsoft or Amazon or the individual persons who are philanthropists or the government people or something like that. How long before they then start saying, yes, this exists? It is quite possible that at the end of this webinar, this just disappears under the carpet. I'm not going to reach the government of Cambodia. I can't reach the government of India or even in America. These are the types of things where the people listening here are encouraged to somehow or other help get the message out. If the message is wrong, let it be shown that it's wrong. But right now, lack of movement is defeat, is failure. We've got to get started with it.
Yeah.
Well, for one thing, Carbon 180 had an article out about they couldn't find legitimately good, acceptable carbon removal credits or something out there. And they ended up giving out. They reported, it's a published thing. They were trying for 5 years. I need carbon 180, contact me, or this type of thing. We can put a project together, but they can't, it's not going to happen because I'm doing it. It's going to happen because they want to finance it, or they want to work with it, or other people want to do with it. And anybody that wants to work with me on here, please do, because that's how we can then get something done.
And that actually is more or less what Joshua just asked. Are you aware of any standard verification process for biochar-derived carbon offsets? Do you know?
No.
nothing exists so far.
I can perhaps mention, I mean, we've had a standardized system with the CDM and the gold standard and all that, but that is a bit shaky because it doesn't fit very well with the Paris Agreement. It fits with the Kyoto Protocol, but not with the Paris Agreement, and it's still under international negotiations, which are delayed at least another year. But not everybody's waiting. There are things happening, various voluntary carbon trading systems starting to appear, small scale and outside of these established verification systems. I think one important point is that biochar came into the IPCC national guidelines for climate accounting in 2019. So that is an international document with some strength. But it's definitely been a delay to biochar, that early attempts to get into this into the carbon credit systems did not work. And I think it's very much because we don't know exactly how stable for how long. And if you really want to know the details there, you might want to wait for more research, but I would say that we know it's stable enough. So it's better to get started, because the climate's not going to wait until we've done all the research. The climate is already changing.
Yeah, I don't think that climate benefit is going to be the driver for biochar in the short term, because the values in agriculture are so much greater. The carbon credits, range from $10 to $30, 10 to 30 pounds or euros a ton, and the biochar is selling for $500 a ton into agricultural applications because of the crop benefits. So I think waiting for the credit to drive the entire process is going to be a long wait, and I don't recommend it. I recommend that the products get utilized wherever they have benefit, and then we'll start to see the cumulative impact of having this stream of this flow of carbon diverted from the atmosphere. So that's just my approach. You can't, waiting for Washington in my case, or Stockholm in other people's cases, to act is sometimes a bad strategy.
Yeah, true. We see in Sweden also the market is growing from the market interest, not yet so much in agriculture, but for urban applications of biochar in landscaping and tree planting in urban areas. And then we're talking high enough prices to drive the market. But when we're talking India, Africa, it's a different story, and those climate credits could really make a difference for financing.
But then you'd have money flowing from the developed countries to the developing countries, which goes contrary to historical practices. We normally extract resources from developing countries and leave them with pollution. So yes, we have some lessons to be learned. Well, thank everybody for their time, and this problem will not go away soon.
I just realized that I don't have my email address on the title in there, but we can put it into the chat, or it's around. It's my website is woodgas.energy. We'll find it. So I'm looking forward to hearing from a number of you.
Okay, I think that that was already quite a nice ending to discuss the broader issue of the future of how biochar might end up saving the world. Let's see, or at least the climate. I think we are 1.5 hours. So thank you very much, Paul, for your presentations. Thank you very much, Cecilia, for your insights, and also Hugh, who I don't see, but I think he's still here. Thank you for discussing this, and if you want to watch it again, you can, it will be uploaded on YouTube in the next couple of days. And other than this, I wish you happy holidays. And next year, we are back in January with the next webinar from Matteo Bertoli.